Good morning, good afternoon, good evening, everybody. This is my pleasure, together with my colleague from the European Space Agency, Joost van Bemmelen, to deliver a presentation in this seventh session on the evolution of the GEOSS platform to make regional capabilities globally available. So you will see here that I'm working for the European Commission as a policy officer. I'm basically managing the EuroGEO initiative together with my colleagues Marianne van Mero and Gilles Ollier. And we are very interested in sharing experience of the EuroGEO initiative and how we have been developing it, including by trying to strengthen the GEOS infrastructure and the GEOS platform, which will be the second part of this presentation. But let's start with a few words about the EuroGEO initiative. So EuroGEO is a well-known and now mature initiative. It was started in 2017 in Washington during the GEO plenary. The work program that supports the EuroGEO is really something that we design with the entire community, and the last one is currently under implementation. Essentially, what our activities are mobilized around a number of action groups that aim at developing pre-operational Earth observation service. But we use as well European Commission, European Union tools and programs like the Horizon 2020 and the Copernicus programs to provide the necessary framework to support the entire initiative. And that includes, of course, relatively large amounts of funding. What is important to mention as well is it's a co-driven initiative between several Commission service and a number of stakeholders from participating organizations in GEO and member states. Just in one slide before passing the floor to Joost, what we consider as the key elements of the added value of EuroGEO is we have succeeded to frame EuroGEO as an incubator, a facilitator, focusing on the downstream part of the value chain and complementing existing programs, namely the Copernicus program, but other European Earth observation supporting initiatives like our Horizon 2020 research program and the space program. So we consider that EuroGEO is a bit the voice of Europe in the GEO community. It engages via its member states and participating organizations in all the GEO flagships, initiative, community activities, but as well in the foundational task. What we try to do is to anticipate as well what will be the coming Earth observation landscape, trying to investigate a new area of interest, like the move towards a service-oriented architecture, how to address in situ gaps, how to include citizens or object-driven observation, how to ensure that we maintain the connection with the science supporting all of this. What you will see now is a number of piloting activities that have been developed with the support of the Horizon 2020 program that show how regional capabilities can be made available globally via the GEOSS platform. And now I will close this first introduction and pass the floor to my colleagues, Joost van Bemmelen.
Thank you for providing me with the possibility to present the evolution of the GEOSS platform and how it makes regional capabilities globally available. And my name is indeed Joost van Bemmelen. I'm working at the European Space Agency in Italy, and I'm involved in big Earth observation data related activities, in particular in data ground segments implementation, operations, and exploitation. So this is a short overview of the GEOSS platform. You will know that it is an evolution of the GEOSS common infrastructure. It was actually renamed in 2018, and it is a shared effort coordinated with the GEOSS Secretariat and the four main component developers and operators, being ESA for the GEOSS portal, CNR for the Discovery and Access Broker, the University of Geneva for the Yellow Pages, and the Federal Geographic Data Committee for the Status Checker. On top, I would like to refer to the European Commission, DG RTD, who co-funded relevant parts of the GEOSS platform development with a grant to ESA and CNR called EDGE, short for European Direction in GCI Enhancements. This project actually ran from October 2017 until May 2020. In EDGE, we recognize that an evolved GEOS should move from a data-centric approach to a user-centric approach, and this is in line with the main challenge in GEO and EuroGEOs. So the GEOSS platform links users with heterogeneous resources from all over the globe. And its evolution in EDGE was built on 3 pillars, being collaboration with the end users and other stakeholders, implementation tailored to the individual users, and reuse of generic tools and instruments. So for this, we coordinated with many regional, national, and international players and initiatives recognizing user centrality as the starting point for evolving GEOs, linking, connecting, and/or interfacing with their community platforms, infrastructures, systems, etc., and as such making their capabilities globally available to others. Many stakeholders have been interviewed and invited to share their use cases and needs for us to evolve the platform and connect to them, experimenting new, evolving and sharing capabilities in response to their requirements, involving them during the full development cycle. Eventually, at the end of the project, more than 30 scenarios were completely implemented and about a dozen even partially. These scenarios consider various perspectives or communities related to the GEO priority areas, which you see at the top of the slide. So these are indeed climate change, disaster risk reduction, and sustainable development goals. We have other thematic areas including water resource management, biodiversity and ecosystem sustainability, public health surveillance, agriculture and food security, and sustainable urban development. We consider regional hubs such as EuroGEO and EuroGEO, but as well the Digital Belt and Road Initiative. And last but not least, we also address some cross-thematic communities. We considered as well flagships, GEO initiatives, community initiatives, as well as regional initiatives. We addressed Copernicus services, Copernicus DIASes, ESA thematic exploitation platforms, H2020 projects, but as well ERA Planet activities. So a whole plethora of stakeholders resulting in more than 100 requirements on which basis we identified capabilities and evolved the GEOSS platform. For some, we provide widgets for them to interface from their own portal with the platform. For others, we implemented mirror sites. Others directly interface via APIs with the DAP. And again, for others, we implemented additional capabilities, either e.g. in terms of search parameters, filters, views, but as well in terms of visualization, harmonization, navigation, and even execution of services. In terms of platforms, we distinguish between an operational platform, which is basically a data platform providing capabilities related to discovery and access of data, and a development platform that we use to provide proofs of concepts, how the GEOSS platform, but as well the GEOSS infrastructure at large could evolve to better respond to the identified user needs, which do not regard data only. So some of the scenarios led to evolution of the operational platform, and others were input to the development platform. And what you see here is those which are marked with a rectangle were input to the development platform. So let's take a look at the operational platform, for which you see here a screen dump. You can do a search via the GEOSS portal using different search parameters and filter results standard, but as well resource specific. E.g., we have specific filters for sentinels, for certain domains, etc. Results can be inspected and, in case applicable, displayed on the map or downloaded. In summary, it is accessible from www.geoportal.org. It implements different types of APIs. We have a set of standard web service interfaces, for example, OGC service interfaces, CCAN, PyPMH, FTP, etc. We have a set of APIs for software development, client-side APIs, used, for example, by the GEOSS portal, and server-side APIs. We have enhanced harmonization capabilities, specific instruments to support user communities, including views, now with nested views. We have widgets, we have mirror sites, we have GeoLike, which provides the possibility to users to give feedback, and which is then dealt with. We connect 191 open data catalogs, more than 45 million datasets, and more than 400 million granules. We provide search with hints from various heterogeneous thesaura, for example, from GRC and sales. And we have domain-specific visualization and filtering, transformation, and bulk capabilities. Then now some examples of the development portal. Here you see the look and feel. As you can see, it is providing a similar search capability as within the operational portal. The results will be displayed, distinguishing between data, information, and services in 3 different tabs. The data is basically the same as in the operational portal. The information tab allows you to navigate via relations identified by knowledge providers, and in the service tab, you can execute services. E.g., if you do a search for land degradation, you can inspect all tabs, but in the services tab, you will find that there is the possibility to run the services that are discovered via a run icon. Clicking on it, a window will pop up that will show the workflow where you can select input data. In this case, the 3 sub-indicators, land productivity, land cover, and soil carbon, using the same GEOSS platform, and you can select the cloud platform where you can run the selected service, here trends.earth. In this case, we can select between running it on Amazon, but as well on different DIASes that can be accessed via a VLab implementation done by CNR. Credits go as well to the Ecopotential and GeoEssential projects. The second example of the development portal shows how you can navigate across information from 1 or more resources or knowledge providers. In this case, from the United Nations Statistics Division. Doing a search for Sustainable Development Goals, all SDGs will be displayed. Selecting then, for example, SDG 15, Life on Land, you will see a right arrow via which you can show all related targets. Via target 15.3, so by 2030, combat desertification, restore degraded land and soil, including land affected by desertification, droughts and floods, and strive to achieve a land degradation neutral world, one can then open the data tab via a dedicated data icon in the target result and show the indicators. And then you can show it on the map or display it on the map with a legend, what you see in the right lower corner. And you can eventually as well compare this with similar data. So in summary, the development portal is available from the following URL, https://geos.uat.esaportal.eu. We consider in the development portal a move from data towards information and knowledge. We cover with the search data, services, and information. And we have dedicated tabs to display the heterogeneous data, information, and services. And it supports the creation of information and knowledge acquisition for decision makers and policy makers to take decisions. Brings me to the last slide of my presentation. Here, actually, we show that indeed we recognize that there is a need to move from data to information and knowledge. We consider this actually as an input to be considered by the GEOS Infrastructure Development Task Team. Based on this, we are starting documenting canonical scenarios. We identified 4 of them. These are actually aligned to what has been identified as well for the implementation of the Knowledge Hub. This, according to us, could be a good input to definition of a logical architecture concerning the whole GEOS infrastructure, on which basis I believe we can directly identify next developments to support stakeholders at local, regional, and global level. So this is then input to such an architecture. May I thank you on behalf as well of Jean, and please visit, let's say, the following URLs for the GEOS portal, the development portal, and the scenarios. Thank you.